right, so the next talk is a short presentation by Simon Msika.
Yes.
I got it right, thank you.
Yeah.
He's a ninja at SynAcktiv. I got it out as well. And the presentation is titled, Implementing Cross-Domain and Cross-Forest RBCD Attacks, whatever that is.
Thank you. So hello everyone, my name is Simon, and today I'm going to be speaking about Kerberos, and more specifically about implementing cross-domain and cross-forest RBCD attacks. Some of you might be wondering, what is RBCD? First of all, what does it stand for? It stands for Resource-based Constrained Delegation, and as the name suggests, is a delegation mechanism in Active Directory, which allows to impersonate users. It is meant to replace and be the more secure version of unconstrained delegation and constrained delegation. But this time the delegation is set directly on the account that will allow users to perform the delegation. And to do this, it uses the msDS-AllowedToActOnBehalfOfOtherIdentity. It's quite hard to say, but is the name of the attribute. So this attribute is populated with the list of users that are allowed to perform the delegation and the impersonation. RBCD is interesting for attackers and pentesters alike because it does not require very high privileges to abuse. We only require the control of an account with a service principal name, so SPN, for instance, a machine account, which is interesting because by default on Active Directory domains, you can add up to 10 machine account per user. And the interesting thing is that a machine account can configure its own RBCD, which makes it an interesting target for NTLM relay attacks. So what usually happens in a pen test is that we are in the network, we have an account with an SPN, so a machine account, and by using Petit Potam, for instance, we can coerce a server to authenticate to us, and we are going to relay the NTLM authentication that we get to the domain controller on the LDAP service, and modify the attribute for this server that we targeted. And afterwards, we are going to be able to impersonate domain administrators on the server. So it's quite interesting. Kerberos-wise, what happens is that, let's say that we want to impersonate ADM user on the service A of the machine. We are going to ask a TGT for the control account that we have that is associated with a service B. We are going to ask a service ticket via the S4U2Self protocol extension for our service for the targeted user. And then with this ticket, we are going to use the S4U2 proxy protocol extension to obtain a service ticket for the service that we want to target for the ADM user. So this is how it works in single domain environments. It has been thoroughly described, but how does it work in cross-domain environments? First, we are going to set up the lab. So we have two different domains, asgard.local and dev.asgard.local. And our goal is to exploit the RBCD from the dev domain. So we have an account, a machine account in the dev domain, and target a workstation in the asgard.local domain. The goal now will be to impersonate a domain administrator of the Asgard domain on the workstation. So to do this, we did like we would in a real pen test. So we use NTLM relay X, coerced the machine with Petit Potam, and since we have a user that is not in the Asgard domain, it is necessary to pass the SID of the user that we control, because it is not present in the LDAP directory of the Asgard domain. So we did this, and now the RBCD was set up. So we tried to perform a standard RBCD. It did not work, but we looked for the Microsoft documentation, which was a little bit lacking. Luckily for us, the Rubeus tool already implemented the cross-domain RBCD workflow. So here's how it works. We are going to ask 2 tickets at first, a TGT to authenticate to the dev domain and a referral TGT to authenticate to the Asgard domain. And then we are going to use the same process, meaning that we get a referral TGT for something and then the real referral ticket and then the real ticket that we want. So we are going to get the referral service ticket via S4Use2Self on Asgard, then use the ticket that we get to get the service ticket for the user of Asgard for our service. And then same, we are going to perform the S4U2 proxy step on the dev domain to get the referral ticket, and finally have the final ticket on the Asgard domain. So after checking this with Rubeus, we tried to perform the same steps with Impacket, and sadly it did not work because Impacket is not really flexible as to the service ticket requests it forges. In particular, the domain that is present in the service ticket request is gotten directly from the TGT that we give as an argument. But this is not ideal in cross-domain operations, because as we can see here from the traffic from the RBCD, the ticket that we pass to authenticate might be from the dev domain, but the service ticket that we perform might be for the other domain. So now we did some modification to the getST script of Impacket to be able to do so. So we were really happy, we got it working, and now we wondered, how does it work for cross-forest? So 2 different domains in different forests. So we basically perform the same step, the coerce setup of the RBCD, but for 2 different domains, Asgard.local and Valhalla.local. And we wanted from an account from the Valhalla domain to perform a delegation on Asgard workstation and impersonate the domain administrator of the Asgard domain on the workstation. So we tried to perform the cross-domain RBCD workflow, because it might be similar, right? Expecting everything to work properly. So we used both Rubeus and Impacket, but to no avail, because in both cases we were met with the KDC error policy. So we were a little bit skeptical, because the KDC error policy suggests that some type of filtering is in place, or at least that's usually when this type of error emerges. So we first thought that the SID filtering mechanism was implied. So we tried to perform this delegation mechanism again, but with unprivileged users, to see if maybe there was some filtering on the domain administrator's SID. So we tried that, it did not work, we got the same error. And then we thought that maybe it was tied to the configuration of the trust between the 2 domains. So we downgraded the configuration to less secure configurations, enabled the TGT delegation, and it did not solve the problem either. So after this, we were a little bit sad, but thank God the Microsoft documentation was here. So we dug a little bit. We found a document, Microsoft Word document, that explained the KDC behavior. I'm not going to read this to you because it's way too long, but the too long didn't read takeaway is that we can only impersonate users in the forest we are currently in. So this is less powerful than the previous RBCD I presented you. But it can still be useful if some privileges are granted to users in different forests. So in our case, since we are in the Valhalla domain, we can only impersonate users in the Valhalla forest. So to study how it worked, we configured administrative rights for a user of the Valhalla domain, v4, and we are going to try and impersonate this user. So we tried again to use Rubeus and Impacket to no avail. So we still had no idea what happened protocol-wise. So our next goal was to simulate the Kerberos traffic of the RBCD delegation mechanism, capture the traffic and study it with Wireshark and try to reproduce it with Impacket again. So to perform the delegation, we used this bit of code that was documented by Will Schroeder and exploit.ph, which will allow to impersonate the V4 user, which is here, and access the workstation, which we configured before with administrative privilege for this user, and impersonate this user. Here is what happened. We noticed that we had the 3 first steps that were the same of a standard RBCD, but on the Valhalla domain. So in a single domain environment, you would expect to have the final service ticket that you want to have. But in this case, we got a referral TGT for the Asgard domain, which was a little bit disturbing. After this, there was another S4U2 proxy, but with different options that was performed. And we got, with this service ticket request, another referral TGT. So we got 2 referral TGTs. And with these both of these tickets, we are able, via the S4U2 proxy, to get the final ticket that we want. So it is really different than the cross-domain and the standard RBCD. So here are the options that we want to pass. It is the branch-aware flag, and we pass also another ticket in the request. The funny thing is that when performing the delegation with the PowerShell code I showed you earlier, there is another service ticket request that is performed on the Asgard domain controller, but the ticket is useless in the process, so there is a ticket that is never used. So finally, we implemented all these steps in the getST script, and we were able to perform the cross-forest RBCD steps via Impacket. And finally, access the workstation as the administrator that we wanted to target. So we can finally close Wireshark and be happy about it. So as a quick conclusion, RBCD in cross-domain and cross-forest environments are different from the usual RBCD. And in particular, we saw that cross-forest RBCD is less powerful than its standard or cross-domain counterpart, but it could still be exploitable in some scenarios in which you have users from a different forest that have interesting rights. In order to defend against these attack paths, the most obvious thing is to prevent scenarios in which NTLM relay attacks are possible, and in order to check if attack path exists, audit the ACLs with blowdown, for instance. Finally, the Impacket code for the cross-domain and the cross-forest RBCD is available on GitHub, on the SynAcktiv GitHub, and there was also a pull request that was made on Impacket. Thank you very much for your attention.
Thank you. Question? Yes.
Thank you very much for the talk. Very interesting. However, I did not really understand how what is why do you need the V4 user for cross-forest, and how is it less powerful? Can you come back on this a little, please?
Of course. So I'm going to take the 2 drawings. In this case, so in the cross-domain case, we were a user from the dev domain, and we were able to impersonate domain administrators of the Asgard domain. So we were in the dev domain and managed to impersonate users of another domain. In the other case, so in the cross-forest case, we are in the Valhalla forest, in the Valhalla domain, and we are only able to impersonate users from the Valhalla domain. So we cannot impersonate domain administrators of the Asgard domain. So this is why I say it is less powerful, because from the domain you are in, you are not able to impersonate users of the other domain. And so in order to simulate an attack scenario that was interesting for us to study, we had to configure administrative rights to a user in the Valhalla domain. Otherwise, it wouldn't be interesting. We would be able to impersonate users of Valhalla, but they wouldn't have any reason to have interesting privilege on the Asgard domain. Is this clear to you? Okay.
Maybe a last question.
No. Okay. Nothing so.
No.
So thanks a lot
Thank you.
again.
Thank you.